So we're going to create our own list, our own data structure instead of using array list here, right? We're going to create our own list to store user account. Let's create a new package and let's name collection. Okay, collections. Just try to use the same name as what we have seen on Java collection package, right? So collection actually it's interface name, so maybe I should name, let's refactor, rename it to like utils, right? Utilities. And we're going to create a new interface, right? If we don't have it, we're going to need to type an interface. See, this has an interface, right? So interface name. All right, so requirements said you're going to have to create stack interface, queue interface, order list interface, and index list, right? So it says here stack has push pop top is empty is full, right? But we just talk about the list. We have add remove contains is empty size get to string reset get next. Just like an interface that we were looking at right here, add remove, right? So for this one, it didn't require you to do everything. If you want to do everything, that's fine, but it's just saying, okay, operations for those are here. You have to implement all of this, right? All of this. So let me show you, for example, I want to create a stack interface, okay? Stack operation is push pop top is empty is full. Okay, so we were talking about let's look at stack interface. So I'm going to name interface, right? Let me know this is an interface. It's not a class. Just name it interface, right? Sometimes people actually don't spell it out like that. Instead, shorten it by iStack. So interface stack. We just start. All the interface start with I, and you may see people doing that. Some people just spell it out. But when you see an interface start with I, and what's an interface? Pretty much just put all the operation that you need here. Push pop top is empty is full size to string, right? So we're going to do the interface now. Push, when you push, and we want this to be a generics, so we're going to do an E, right? E. When you push, what is the return type? Push, just like add. So in the stack, let's talk about stack data structure, right? So let's talk about stacks, right? So this is going to talk about all the stack ADT. ADT stands for abstract data type. So what does it mean, ADT? Abstract data type means if you look at Chapter 2, it's going to explain ADT into details, right? So let's talk about this first. Then you understand why interface. Okay. So abstraction is a model of a system that includes only the detail essential to the perspective of the viewer of the system. Information is hiding. Like for example, when we talk about your iPhone, it's actually an abstract, iPhone, but how it really works is being hidden in that case, right? An engine of the car, we know is an engine, but how it functions is being hidden. So it make it abstract, right? Now data abstraction. So separation of the data type's logical properties from its implementation. All right. Abstract data type, a data type whose properties are specified independently of any particular implementation. Exactly that's what we want to do here, right? Stack is the ADT. Operations are push, pop, top, just like array list. You do dot add, you do dot remove. You don't have to know how it's being implemented. It's being abstract to you, right? So that's array list ADT. Same stack has push, pop, top operations. You know that when you push, okay, when you push to the stack, what happened? Look at the stack. It's like stack of trays, stack of coins. It's gonna be like that. Push, just keep adding on the top of each stack. So we call last in, first out. You may see the last one that on the top always going to be the first one that go out of stack. So that is the push operation here, right? Pop, pretty much just pop the one on the top out. Just remove from the stack when you pop. Like for example, if I push 2, I have 2. If I push 3, I have 3 on the stack. Push 5, have 5. Pop, 5's gone. Push 4, right? So this is stack operations. And now when you do top pretty much just you don't pop, you just peek. You just look at what is at top, but you don't remove at the top. That's top, right? Not like pop always remove at the top. Is empty, we just return if the stack is empty, is true, right? Otherwise false is full. That's why we use parenthesis array. Okay. To implement, if you use an array, you have to define the size of array. We know that. Then if you define the size like 10, then you can only add 10 items onto the stack, and it's gonna be full. Size, if you have 2 items, it's return 2 on the stack. ToString pretty much just print everything in the stack out. Okay, so these are the operations for the stack. And now when we talk about ADT, you understand why we said ADT, right? Now for your test, this is going to be on your test, okay, like this. What is the application levels? Like ADT has the levels, 3 levels: application, logical, implementation. And application level is pretty much just we use the ADT to solve the problem, like you use array list. You use a level. So when you're working at this level, we only need to know how to create instances, like you instantiate an array list, right, of the ADT, and how to invoke operation dot operators. That's it. This is application level. The logical or abstract level provides an abstract view of the data values and the set of operations to manipulate them. At this level, we deal with the what question. What is ADT? What does it model? What are its responsibilities? What is its interface? So this is an interface level. That's why when I try to create an interface, I'm at the logical level here. All right, what is this ADT for? I'm saying iStack is right. This ADT has what are the operations? What does the interface look like? So this is the logical level here. So we know we're going to create push operation, and we have to pass in the element to push e, right, element to push, and we don't worry about implementation. This is logical level. Again, Abstract view of the data values and the setup operations, right? Push, pop, top to manipulate them. At this level, we deal with what should be the operations here, right? What does the model, what are its responsibility? So I'm at the logical level here. So I'm going to do another one. Pop should return E, the element itself, right? Pop and just pop, no parameters. Pop at the top. Top is going to same, but you don't remove. Return what's at the top, right? Is empty, so Boolean then, right? True or false, right? Is empty. If the stack is empty, is full. Boolean again is full. Size is going to return integers, right? How many values are there, right? And lastly is toString. And normally toString is just part of the class. We don't really have to include an interface. Because other classes should have toString. Like when you do system.out.print your array list, it always print out the contents out because it's called the toString of array list. So that is an example. Now, if you use an array to implement, right, it's gonna have isFull. But if you use a linked list, there's no isFull. Linked list is keep adding it. So let's review that one more time. We talked about that once. Let's look at array and linked list on chapter 1 again. This is an array. You specify the size, so you cannot have more than 6. That's a size 6. isFull is going to be true, but linked list, there's no such full. You just keep adding to the next node. Still at the logical level. And we said linked list and array. Now let's see how do we create an array and how do we create linked list. If we have to create, we're not talking about logical level anymore. We're talking about implementation. You provide specific representation of the structure to hold data and implementation of the operations. You're implementing it. So that's the implementation level of the ADT. Okay. All right, so you see that on the test. That one is going to be on the test, that page of slide. Now you understand, right? The levels. Now, let's see if I want to implement a stack using an array. Then I use isFull, right? One thing about this is, what happens if I implement a stack using a linked list? Okay, let's look at this. I'm going to create a new class named stacks. I'm going to say bounded stack. Bounded means there's a boundary because you're using the array. You have to implement I stack, right? And make sure it's E because we're going to support any elements. This is a generics, right? Now you're required to implement an unimplemented, right? Like every method in the stack. Otherwise, it's going to keep warning like that.